Welcome everyone, and in this video I'm going to talk about entropy, which is just a measure of randomness in a given system. It is one of the branches of chemistry that help us explain a lot about how matter exists in nature in terms of distribution of particles. Now, to define entropy, simple thing that you need to know is just measure of randomness. Or disorder. It is entropy that helps us explain how particles behave in nature. So we can measure the randomness or disorder of particles in a solid state, in a liquid state, and also in a gaseous state. Now, to understand entropy, there are key things that you need to know. First thing, that entropy entails particles of chemical elements. And whenever particles of elements are undergoing changes, also their surrounding affects their behavior. So surrounding really affects the behavior of particles as they undergo chemical reactions. Now, we can calculate total entropy change of a given system. Imagine a situation whereby I'm reacting sodium plus chlorine. If I decide to react sodium and chlorine, let me just write it chemically. Sodium plus chlorine. I know very well that at the end of the day I'm going to form sodium chloride. Chlorine is a gas. Now, this reaction happens in nature, and the product we are going to form is this. But the key thing that we have to know is that a reaction can either be exothermic or endothermic. And for a reaction to go to completion, if it's an exothermic reaction, heat will be produced. If it's an endothermic reaction, heat will be absorbed for that given reaction to take place. So entropy enables us to understand the behavior of energy changes whenever particles are being distributed in a given system. So to understand entropy and the calculation of total entropy, the first key thing that we need to take into consideration, is entropy change of a given system. Of a system. Is always denoted by delta S. The next thing that we have to take into consideration whenever we are calculating total entropy is the entropy change of the surrounding. And it is always denoted as delta S Now, the key thing that I would also like you to understand here is that this knot means that this reaction is happening under standard condition, and the standard condition here means a temperature of 25 degrees Celsius or 298 Kelvin, and also the same reaction is happening at 1 atmosphere pressure. So those are the standard conditions that we need to take into consideration whenever we are calculating total entropy of a surrounding or total entropy of the system. Now, in this video, I'm going to focus much on calculation of total entropy of a system. Now, a system here is just the chemical substances undergoing a reaction. They're the chemicals substances that are undergoing reaction. Now, to calculate it, there are key things that we need to know. First, we need to know the formula that we use whenever we want to calculate total entropy of a system. And to calculate it, I'm going to have a chemical reaction that is yielding products. So on one side, I have the reactants, and on the other side, I have my products that are formed. So if, for example, I was using sodium as an example, plus chlorine gas, and I'm yielding sodium chloride solid. If I want to calculate total entropy, I will take total entropy of a system. I will take summations, and in summation we always use this sign, summations of entropies under standard conditions of products minus summations of entropies of reactants. This is the formula that we are going to use in calculation of entropy of a system. And to shed more light into whatever thing that we are going to do, I'm going to give you an example in which I'm going to give you an example of certain substances and their entropies that have already been calculated. Now, for example, I'm going to have a situation whereby examples. So the first substance I'm going to start with is a substance that is in solid, and on the other hand, I'm going to have entropy that is S naught in joules Kelvin per mole. Now I'm going to start with the entropies of certain solids. Now the first one I'm going to start with is water solid. In solid state, that's one I mean ice. It has entropy of 47.7 joules per Kelvin per mole. Carbon dioxide has a total entropy of 2.4 joules per Kelvin per mole. Graphite has an entropy of 5.7. If you check your data booklet, calcium oxide, I'm just giving you a sample of them because these are the ones that I'm going to use in the examples of calculations that we are going to do here. It's 39.7. Calcium carbonate, it's 92.9. Those are examples of solids. I can also go ahead and give you examples of liquids with their entropies. On the other hand, I'm still going to have just their entropies given in joules per mole per Kelvin. So water as a liquid, I'm still using water here. Now as a liquid, has a total as an entropy of 69.2. Methanol, CH3OH, has an entropy of 239.7. I can also have my ethanol, CH3, CH2OH, has an entropy of 160.7. Can also have E6H6, which has an entropy of 172.8. Now, those are the examples I have of liquids with their entropies. I'm also going to give you an example of gases and their entropies given in joules per mole per Kelvin. And I'm still having water as a gas here, now in vapor, has an entropy of 188.7. Hydrogen gas has an entropy of 130.0. Oxygen has an entropy of 205.0. Nitrogen has an entropy of 191.6. Carbon dioxide has an entropy of 213.6. And lastly, ammonia has an entropy of 192.3. Now these ones are examples of just certain elements and compounds that have their entropies already given in most data booklets that we always use in learning. Now we've known very well that, as I've said, to calculate entropy of a system, we really need to come up with a way, and we've already devised a formula that we can use. And the formula we've said is we're going to take entropy of a system is equal to summations of entropies, total entropies of products, minus summation of total entropies under standard condition of reactants. And for that matter, We are going to start with an example. You can be given a question like this, that calculate total entropy of a system for the following reaction. And I'm going to write the question down. It is going to be our question 1. And we are being asked to calculate of the following reaction. And the reaction we are given is nitrogen gas reacting with 3 moles of hydrogen gas to give us 2 moles of ammonia. Now, when you are given a question like this, we already have the formula. So the key thing, we just have to key everything in to our formula and know what we are going to deal with at each and every stage. So the first key thing we need to be doing here is to fix everything in our formula. So we are going to have a situation whereby now our total entropy, the standard condition of the system, is equal to summation of total entropy of our product here is ammonia, and we have 2 moles of ammonia. So it is going to be 2 times NH3 gas minus that of the reactant. And reactants that we have are 2. So we're going to have summation of total entropy under standard conditions of nitrogen gas plus oxygens are 3. So we're going to have 3 times oxygen gas. Then I close that given bracket. So this is the formula that I'm having here, and I've already keyed in everything. So my work is just to go back to the data that I was having here initially and pick each and every substance that I need according to my example. So nitrogen, in the gas section, nitrogen had entropy of 213.6. We know that. Ammonia, ammonia is 192.3. So those are the key things that we're going to fit in here and come up with a given calculation that at the end of the day we are going to get its answer. Now, so let us try that. So I know very well that my total entropy under standard condition of a system is going to be 2 times that of ammonia. We had already known that ammonia had 213.6. I close the bracket minus, I'm having a bigger bracket, then nitrogen. I'll go back to my data there. Nitrogen was 213, ammonia was 192. Sorry, let me correct that. I'm supposed to have ammonia is 192, so I'm supposed to put 192 here. 192.3. And now nitrogen is what where we have 213. So I'm going to have 213.6 plus oxygen is 3 times. Then we go back to the oxygen section, and oxygen is 205. Yeah, oxygen is 205. I'm going to bring in 2.5.0. Yeah, then I close the bracket. That's what I'm going to have. So you take your calculators very well and do that calculation faster. I'm pressing mine, so you can also do yours at the same time. I'm going to have 3 times 205. Then I add 213.6 213.6. Then this whole thing is going to give me 828.6. Then this other one here is going to be 2 times 192.3, which is 384.6. 384.6. I'm supposed to do minus there. When I do that minus, the value I'm going to get the total entropy of the system here is going to be minus 444, but all these values were given in joules per Kelvin per mole. This is our answer that we are getting at the end of the day as our total entropy or entropy of the system. I can just call it entropy of the system. Now, that's my first example. I can do another example faster. And now I'm not going to wait for you to do the calculation. I'm just going to go direct to the calculation. My example 2 is going to be example 2. We are told calculate calculate entropy of a system for the following reactions, and we are given calcium carbonate solid is being decomposed to form calcium oxide, still a solid, plus carbon dioxide gas. If you check very well, the reaction doesn't need balancing, so we simply go direct into the calculation. And in our calculation, we're going to write the formula. We're going to write the formula. I'm going to key in everything. Now, if I go direct and pick the values that I'm having and I key them in, you can go slowly, but with me, I'll go a little bit faster. So I'm going to have a situation whereby I'm having 39.7. If you confirm the values that I gave on top, plus the value we are going to get is 160.4 joules per Kelvin per mole. So this is how we can do a lot of calculation based on calculation of entropies of a system. So you can do a variety of them. Already I've given you values for substances which are in gaseous state, those substances which are in liquid state, those substances that are in solid state. So you can try different type of chemical reactions that entails those substances that are already given on the table here. You can do a calculation, take a screenshot of it and share with me in the comment section, or you can ask me a question. If there is any part that you don't understand, we can go through it together. Thank you very much and have a wonderful time.